So in this session, let us try and understanding the beauty of impulse response of the system. Right now, first of all, what do we mean by impulse response? Already we have been studied about four type of signals. Right? Just I have given the introduction for four type of signals. When we are giving, that is when I have given the introduction for Laplace transformation. Of course, there we saw four type of signal. One is called impulse, and then step, and then ramp, and then parabolic signal. Now, first should try to get the meaning of impulse signal. What do we mean by impulse response of an LTI system? Right? First, we have to visualize impulse. நான் என்ன சொல்றேன், impulse அப்படிங்கிறது a short time, a fraction of time. Yeah, that is a huge amount of energy which suddenly released in a fraction of time. That is best example is our bomb, right? Or your nuclear fission. Nuclear fission na நம்ம பவர் பிளான்ட், நியூக்ளியர் பவர் பிளான்ட்ல எனர்ஜி நம்ம ரிலீஸ் பண்றோம் இல்லையா? நம்ம இந்த 12th ஸ்டாண்டர்ட் பிசிக்ஸ்ல கூட நம்ம படிச்சிருக்கோம், right? Fission reaction, fission fusion அப்படினு சொல்லிட்டு some terms will be there. அங்க என்ன ஆகும், அந்த atoms வந்து ரிலீஸ் ஆகும், right? In a fraction of second, when the moment we are trying to release the atoms, right? Atom வந்து நம்ம collide பண்ண விடும்போது they will bombard, right? So அவங்க collide ஆகும்போது என்ன ஆகும் அப்படினா they will burst. அப்படி burst ஆகும்போது என்ன ஆகும் அப்படினா that nuclear fission will release infinite amount of energy. But that infinite amount of energy will be completely shielded in a particular box with high quality devices. Use பண்ணி அதை shield பண்ணி that infinite amount of energy will be utilized. It can be utilized as a heat energy. With that we are creating the steam, that is water on the heat பண்ணி with the help of steam we are running the turbine so that our power will be generated. Yes or no? Yes. Now impulse in the sense, actually what do you mean by impulse? That infinite amount of energy, that is releasing the infinite amount of energy in a fraction of second is called impulse. Now what I am going to do, with the help of the impulse signal we are going to test our systems, right? Of course we are in general control system in the sense we are in general. As a control engineer I cannot design, that is I cannot specifically define, that is I am designing the, what I can say, I am talking about electrical machine, or I am talking about synchronous machine, or I am talking about generator, like that I cannot define. I am designing as a control engineer. My what is my intention? I have to design a general transfer function for your second order systems, first order systems, zeroth order systems. I have to generally define all things so that the general order will going to be applicable for the universal existence. Right? நீங்க எந்த ஒரு சிஸ்டம் எடுத்தாலும் அந்த சிஸ்டம் என்ன வரணும், in my point of view that will be அது எந்த இதுக்குள்ள வரணும் அப்படினா நான் டிசைன் பண்ண ஒரு சிஸ்டம்க்குள்ள அது வரணும். So universally I am looking for all the things, right? I am looking for, right? அதுக்கு அப்புறம் நான் கன்க்ளூட் பண்றேன். நம்ம universally exist ஆகிற சிஸ்டம்ஸ்லாம் zeroth orderல ஒரு சிஸ்டம்ஸ் இருக்கு, first order systems are there, second order systems are there, third order systems are there, fourth order systems are there, higher order systems are there, type of systems. What do you mean by type 0 system, type 1, type 2, like that? Actually I am generalizing all the things because I am a control engineer. I should design in a control, that is in a general way I should design some system so that in that system you can categorize. உங்க சிஸ்டம் வந்து என்னோட டிசைனிங்ல எந்த மாடல் உள்ள வருது, டைப் 0 ஆ, டைப் 1 ஆ, டைப் 2 ஆ, ஆர்டர் 1 ஆ, ஆர்டர் 2 ஆ, ஆர்டர் 3 ஆ, ரைட்? அது நீங்க பார்த்ததுக்கு அப்புறம் என்ன ஆயிடும், I am going to give some general response. லைக் செகண்ட் ஆர்டர் சிஸ்டம்னா ஜென்ரலாக இப்படி தான் இருக்கும். அப்போ நீங்கள் என்ன பண்ணலாம், நீங்கள் டிசைன் பண்ணுற சிஸ்டம், நீங்கள் வந்து ஸ்பெசிஃபிக்காக ஒரு சிஸ்டம் வந்து டிசைன் பண்ணுறீங்க, ஒரு இண்டக்டர், ஒரு கெப்பாசிட்டர், ஒரு ஆர்எல்சி சர்க்யூட் நீங்கள் டிசைன் பண்ணுறீங்க, அதுவும் ஒரு செகண்ட் ஆர்டர் சிஸ்டம் தான். செகண்ட் ஆர்டர் நம்பர் ஆஃப் ஸ்டோரேஜ் எலிமெண்ட்ஸ் வில் டீல்ஸ் வித் ஆர்டர் ஆஃப் தி சிஸ்டம். நம்பர் ஆஃப் இண்டிபெண்டன்ட் ஸ்டோரேஜ் எலிமெண்ட்ஸ் வில் டிஃபைன் தி ஆர்டர் ஆஃப் தி சிஸ்டம். ஸ்டோரேஜ் எலிமெண்ட்ஸ் in the sense inductor and capacitors combo will create the order, not your resistor, because resistor don't have the ability to store the energy or deliver to someone, right? It will convert the energy, that's all. So storage elements only will going to take independent storage elements, independent, they are not dependent each other. So independent storage elements will going to take the responsibility for the order of the system. Okay sir, so what is my responsibility? First I have to universally see all the common type of existence, right? And I have to design, okay, there are some from this I can generally categorize. I am going to categorize type 1, type 2, type 3, 0, first order, second order, third order, higher order systems, and then after classifying all those things, right, generally I have to test them, right? I have to test such that இப்போ நீங்க என்ன பண்ணீங்க அப்படினா you have to test ஒரு சிஸ்டம் எடுத்துக்கிட்டு அந்த சிஸ்டம் வந்து நீங்க கம்ப்ளீட்டா டெஸ்ட் பண்ணி நீங்க கொடுத்துட்டீங்க அப்படினா இந்த மாடல்ல வர எல்லா சிஸ்டம், for an example listen, I am going to design a circuit breaker. I am going to design a circuit breaker. Now I have to define a rating for your circuit breaker. How much amount of voltage that is going to be dropped across the circuit breaker, whether it is 11 kilovolt or 22 kilovolt or 32 kilovolt. For your understanding I am going with the power system components, right? So அதை டிசைன் பண்ணதுக்கு அப்புறம் என்ன பண்ணணும், I have to test the ability of your circuit breaker. For that, for an example, this circuit breaker has been defined for, that is has been designed for 11 kilovolt. Now suddenly in a fraction of second I am going to pass 11 kilovolt and I have to test whether the circuit breaker that is holding that 11 kilovolt or not. right? So once on the fraction of second 11 kilowatt inject பண்ணும்போது, if that circuit breaker is holding, yes, you can inject. I am waiting for you. I am waiting for this 11 kilowatt only. I can accept, I can hold, I can stop this 11 kilowatt, right? I can hold this 11 kilowatt. Such that அது நீங்க எப்படி டெஸ்ட் பண்ணணும்? With the help of impulse. With the help of impulse, right? So in the same way, we might also talk about insulators. In our power system, insulators are there. 11 kilovolt, 22 kilovolt, 33 kilovolt ratings insulators are there, right? So that insulators are directly tested in the laboratory, right? As a control engineer, I have to test. I have to test the laboratory and the specific equipment. I have to pass the impulse signal. What is the rating of the circuit breaker? 22 kilovolt. Suddenly inject the 22 kilovolt and test the ability of the circuit breaker. That is an insulator, whether it is accepting the 20 kilovolt or not, 22 kilovolt or not. If it is not, then that circuit breaker, then that insulator will be failure model. I have to improve the characteristics of the insulator such that அதுக்கப்புறம் என்ன ஆகும், once அந்த fraction of secondல நீங்க அப்ளை பண்ற impulse signal ஒரு சிஸ்டம் வந்து தாங்கிடுச்சு அப்படினா அதுக்கப்புறம் you can apply any type of signal through that system. I told you these things already. So impulse signal is a signal, it will be used to test the property of the system. It will be used to test the ability of a system. It will be used to guess the characteristics and the performance of the system in the highest peak point. Peak point in the sense, huge amount of energy will be applied on a single device and it will be tested on the output side. Performance and the characteristics of any system, any systems can be predicted. Ability of the system can be predicted with the help of the impulse signal. Once your system is affecting, that is once your system is accepting the infinite amount of energy, that is impulse signal, then the system is ready to accept all type of signal. So that's why the impulse signal is called a test signal. அப்போ ஒரு சிக்னல், ஒரு சிஸ்டம் வந்து இம்பல்ஸ் சிக்னலே தாங்கிடுச்சு அப்படின்னா, அந்த இம்பல்ஸ் சிக்னலுக்கு அது ரெடி ஆயிடுச்சு அப்படின்னா வேற எந்த ஒரு சிக்னலை கொடுத்தாலும் that system is ready to accept. ஓகே, நான் இம்பல்ஸே அக்செப்ட் பண்ணிட்டேன், நீங்களாம் யார் எனக்கு அந்த மாதிரி வந்துடும். ஸோ that is why we are mainly keeping our concentration with the impulse signal, right? Let us see. Not a big thing. In your exam point of view, some signal will be given, right? First, we should visualize the meaning of the impulse response, right? I hope you all remember when I was talking about the impulse response, right? Impulse signal, I said the value of del of t in the point of area. You have to observe the area of the del of t. It will always be maintained as del, 1. So Laplace transformation of the impulse signal will always be equal to 1 in S domain. I can say in time domain your signal will be considered as del of t. When the moment I am passing this impulse signal, that is its Laplace will always be equal to 1, right? Now in your exam some system will be given to you, right? Some system will be given to you. Let me define, right? Just understand, right? Now for an example, now I am taking one component or one system. That system will be given to me 1 plus s, that is the given system. Now I would like to test, or I would like to know the response of this system. I would like to know the response in the sense output. Response in the sense output. From this moment onwards, slowly inject the poison. Drop. One drink, ஒரு பாட்டில் எடுத்து உடனே குடிச்சாதான் நமக்கு பிரச்சனை. But daily if I drink small drop amount of poison, then what will happen? Your body will develop the antibiotic for your poison. So that what will happen, after a long time your body will get the ability to accept the poison also. Your body will be affected because of அப்போ நீங்க ஒரு ட்ரிங்கே குடிச்சாலும் ஒரு கப் குடிச்சாலும் அதுக்கப்புறம் என்ன ஆகுது, it won't be. Test பண்ணி பார்த்துட்டாங்க. Just I am saying, that I am giving some examples. So the thing is, I am just testing the response, right? Slowly I am injecting in your mind, right? It's like a poison. Response in the sense that is output of the system, right? Correspondent input. The thing is, find out the response, find out the impulse response of the given system. Question is, find out the impulse response of the given system. Now impulse in the sense del of t. Anyway, I told you, keep all your signal always in S domain, because in time domain your signal will always be convolved with your system, so that in time domain your output of the signal will going to be the multiplication, convolution, right? Your signal will be convolved with your system, g of t, right? So in S domain what you can do, in S domain you can multiply. If any signals are converted in time domain, they will be multiplied in S domain. Suppose if my signal is converted in S domain, then that signal will be multiplied in time domain. We will see rest of things we will learn slowly in signals and system, because signals and systems especially that subject will be created to understand the beauty of the signals and the systems in a separate way, right? We will deal with them later, but not now, right? I am going with control systems, right? Universally exists, that is universal existence, right? Common designs, common systems, right? So here in time domain, if any signals are convoluted, then in S domain they are going to be multiplied. So what I can say, C of S can be written as in S domain, Laplace of C of t will going to C of S, Laplace of R of t will give you R of S, dot dot, I'm putting multiplication because in S domain, Laplace of G of t will give you G of S, of course should keep capital. I said to differentiate, we are in time domain, use small letters, in S domain we are using capital letters to differentiate, that's all, right? So the thing is, question is find out the impulse response. Now we know in time domain your impulse signal will be defined as del of t. In S domain its corresponding value is going to be 1. See that 1, right? Now this is going to be your G of S, of course. This is going to be your R of S. Now output of the system can be written as R of S into G of S. Now luckily my input of the system is going to be 1. Input of the system is going to be 1 into G of S is equal to what? G of S is equal to 1 by 1 plus S. So what we have understood here, impulse response of the system. G of S equal to 1 by 1 plus S. What about the C of S? C of S also equal to 1 by 1 plus S only. See, should try to get the beauty, right? Should try to analyze the beauty of the system, right? So what I have understood from here, if my system is getting tested by impulse signal, if my system is getting tested by impulse signal, under that condition, my system value will be equal to response. C of S and G of S will always be equal. That is the most important point always. Now from this moment onwards you have to register. So what is the conclusion here? The conclusion is output response of the system, right? Output response of the system C of S is nothing but Laplace of G of t. I can say in time domain it can be written as G of t. Laplace of G of t, or I can simply write G of S. Impulse response, right? Impulse response in the sense, this is your impulse response, right? So what I can conclude, impulse response or C of S, that is written as impulse response is nothing but Laplace of my G of t or system. Why impulse response is nothing but C of S? That should be equal to what? G of S. Clear? So அப்ப நீங்க impulse என்ற word பார்த்தீங்கனாலே இதுக்கு அப்புறம் மைண்ட்ல வந்து output system equal தான். That's all, right? Now from this, how we are facing the questions? Let me conclude, right? Actually, this is all about impulse response. Questions, how we are facing the questions with the help of these impulse responses. The questions are given like this: impulse response, right? Impulse response of a system given like this, right? Impulse response of a system. System பத்தி எதுமே பேசிக்க மாட்டாங்க, right? System பத்தி they did not give any values. Like it will be given as G of S, and it will be given as C of S, and it will be simply given as R of S. It will be simply given as R of S. Now the question is, right? First statement என்ன கொடுத்துருவாங்க அப்படின்னா, that is the famous repeated model, but many of you are getting struggling at this point because without understanding the meaning of this system only. Now we will get the clear idea. The question is impulse response of the system. First one என்ன கொடுத்துருவாங்க அப்படின்னா, impulse response of the system is given as 1 by s plus 1 or s plus 2 something. It will be given. Impulse response of the system is 1 by s plus 2. Now find out the step response. That is the question. Step response. How will you find out? First you should think. என்ன meaning அப்படின்னா, listen. There is some system. அங்க ஏதோ ஒரு system இருக்கு. அந்த system உடைய impulse response in the sense, impulse is going to be your input, response indicate the output. இதோட மீனிங் என்ன அப்படின்னா, through a system is not known, through a system if you are passing the impulse signal ஒரு சிஸ்டம் வழியா நீங்க பாஸ் பண்ணும்போது உங்களோட அவுட்புட் ரெஸ்பான்ஸ் எவ்வளவு வந்திருக்கு அப்படின்னா 1 by s plus 2. Output response is given as 1 by s plus 2. But just now we saw whenever we are passing the impulse signal, Laplace is going to be 1. Whenever we are passing the impulse signal through a system, under that condition, C of S and G of S are going to be equal. From this, given it is C of S, response is given as C of S, right? For the impulse input வந்து நீங்க 1 கொடுக்கும்போது output வந்து 1 by s plus 2 வந்திருக்கு அப்படினு சொல்லிருக்காங்க. From this I can conclude, whenever I am passing the impulse through any system value and response values are equal, so I can say G of S is going to be 1 by s plus 2. Why? Because in impulse response I know G of S and C of S are equal. That's all. That is the only key that you have to find. Once you find the g of s, now next question is what? Find out the step signal pass பண்றாங்க. Laplace of step is 1 by s, right? Now through the same system. Now we know the LTI system. System is how much? 1 by s plus 2. Now the question is find out the response. Find out the response for step input. Step input is 1 by s through the system. System value is find out. Previously they did not give. They given the clue, but they did not talk about g of s. We found the value of g of s. With the given clue, we found the value of g of s. G of s is fixed. Now the question is in the same system, find out the step response. Step is input, response is output. We are talking about output. Now what is the output? C of s is known as the product of input r of s into dot g of s. Just now we found r of s is how much? That is going to be 1 by s dot g of s is how much? 1 by s plus 2. Like that is how we are finding. So this is going to be overall response of the system. Now if you want to write these values in time domain, you know how to write. Like you can apply partial fraction. It can be written as a by s plus b by s plus 2, and then you can find out the value of a and b. If you find the value of a, actually a is going to be 1 by 2, right? So 1 by 2 dot 1 by s. Similarly, if you find b is going to be minus 1 by 2 dot 1 by s plus 2. If you find the value of a and b with the help of partial fraction, you will get this answer. Now from this I can write 1 by 2 is common, 1 by s Laplace is u of t minus 1 by s plus 2 become e power minus 2t into u of t. Now this is the correct answer, right? In time domain you can also convert, right? If you want to convert this function from s domain to time domain, you can apply partial fraction. Why I am applying partial fraction? Why? Because in the denominator I have more than one root. If you have only one root, we can directly take inverse Laplace. But now I have two roots in the denominator. There is no option. I must go up with the what? Partial fraction, and then find out how many arbitrary constants should be required. Two poles are there, so two arbitrary constants should be required. And then find out the value of a and b. Substitute the value of a and by b here, and then take the inverse Laplace, so that you will get the value of c of s in time domain. Because in exam questions will be asked in many ways, right? And the second thing is listen, guys. Question idhe model la kekanuma, not like that. And sometimes g of s will be given to you, and you are supposed you are tested to find out the value of c of s. Like that, enna venalam kekkalam. But you know one thing, in impulse response c of s and g of s are equal, and input is going to be 1. And the clue mattum unga mind la irundha podum, rest of remaining all question, that is you can play with your impulse response system. Now we understood the physical meaning of impulse response. We also found we also saw how to crack the questions in our exams whenever impulse response is given. Okay, so this is all about impulse response. Already we saw the stability, right? Stability will deals with the poles location. I said don't talk about zeros, just forget zeros. Only consider poles. If my poles are located in the left half, it might be placed in the complex domain or real domain. The thing is, I have to keep my poles in the left half of exponent, system will be stable. If I keep my pole, single pole will be placed at the origin, marginally stable. One pair of pole in the complex pole, exactly imaginary axis la center axis la vertical plane la center axis la ஒரு pair of pole vandadhu appadina system is marginally stable. But in center of on the vertical line la, if I have repeated roots or two pairs, repeated pairs, rendu vandalum system will be unstable, right? And the third conclusion is whichever the pole, it may be complex, real, I don't want that name, but if it will be placed in the right half of the exponent, system will be unstable. So stability is completely over. So in the next session, right, we are going to discuss about the error analysis. Error system and the error la eppadi varudhu, how to compensate the errors at all, right? First we will complete the errors, and then we will start analyzing the time domain. That is, we are going to start time domain analysis. We are going to test the systems directly in time domain, right, with the help of Laplace, and then we will move to the frequency domain, right? Thank you all.